Software testing techniques. Software testing is a critical phase in software development lifecycle, ensuring the quality, reliability, and performance of software products. In the realm of software testing, two primary methodologies regime supreme: manual and automation testing. Each approach has its own merits suited for different contexts and requirements within the software development process.
Manual testing and automation testing offer distinct advantages for various testing scenarios. Understanding these parameters aid in informed decision on testing methodology. Parameters, as you can see in the table. First one is automation testing. In manual testing, test cases are executed by human testers. In automated testing, test cases are executed by software tools. The process time, manual testing is time consuming, but in automation testing, it is faster than manual testing. Resources required for manual testing requires human resources, but in automation testing, it requires only automation tools and trained employees. In terms of reliability, manual testing is prone to manual errors, but automation testing is more reliable due to automated tools and scripts. Coming to the framework requirements, manual testing doesn't require any frameworks, but automation testing requires frameworks like data driven and keywords, etc. In terms of performance testing, manual testing, it is not possible to do the performance testing, but in the automation testing, this includes like load load testing, stress testing, spike testing, etc. When to use manual testing: explanatory testings, usability testing, adhesive testing. In automation testing, regression testing, loading testing, performance testing.
First, let's have a look at manual testing. There are three types of manual testing: white box testing, black box testing, gray box testing. Let's begin our exploration with black box testing. Black box testing is a fundamental approach in manual testing. Here, the tester focuses solely on validating functionality of code.
Within black box testing, we encounter several types, each serving specific purpose. Functional testing ensures software function meet requirements without inspecting source code. Covers UI, APIs, database, security, more. Can be either manual or automated. Regression testing validates code changes or system updates haven't introduced new errors, ensuring compatibility between old and new code. Third one is non-functional testing, or known as NFT. Assess performance, usability, scalability, and other non-functional attributes beyond functional requirements, complements functional testing. Black box testing operates on premises that tester doesn't need internal knowledge of software. Testing objective ensures that software meets requirements and specifications by testing functionality. Knowledge level: no need to understand internal working, suitable for testers without programming knowledge. Testing method: black box testing uses methods like equivalence partition, boundary value analysis, and error guessing to create test cases. Scope: black box testing is generally used for testing software at the functional level. Now let's look at white box testing. White box testing analyzes internal work of software. Testers has access to source code to design test cases, ensuring logic, flow, and structure meet requirements. Complements black box testing. Within white box testing, we utilize specific techniques. First one is statement coverage. Tests each code statement at once, covering every line of code or node in a flowchart, identifies faulty code. Second one is branch coverage. Ensures each branch from decision point is transversed at least once, covering all edges in flowchart. The objective of white box testing include ensuring internal code correctness and efficiency. It demands a high level of knowledge including programming, architecture, and design understanding. Methods employed in white box testing include control flow testing, data flow testing, and statement coverage. This testing approach is applicable to various levels including unit integration and system testing. Gray box testing. This testing is a combination of both white and black box testing.
As I said earlier, gray box testing represents a fusion of both black box and white box techniques. Testers possess partial internal knowledge, allowing them to design cases exploring both functionality and internal logic. It aims to uncover defects beyond those detectable through black box testing, leveraging the benefits of white box approach when applicable. The internal structure is partially known in gray box testing. Access to internal data structure and algorithms of test case design. Software is seen as semi-transparent or gray box. Focuses on context-specific errors, especially in web systems. This relies on requirement-based test case generation.
Coming to gray box testing techniques that we utilize. First one is data driven testing. Design cases based on internal data knowledge and input handling. Second one is state transition testing. Covers software testing with partial internal knowledge. Third one is regression testing. Focuses on areas where modifications might affect functionality, leveraging a partial understanding of internal changes.
Now let's look at automated testing. There are various types of automated testing like code testing, regression testing, unit testing, integration testing, acceptance testing, performance testing. But today we are going to focus on top three widely used automated testing. These are unit testing, integration testing, and regression testing. Our first stop is unit testing. Unit testing is a crucial software testing technique where individual components of software, such as functions or procedures, are tested for functional correctness. It is performed during the development phase, usually by developers to identify any issues within the independent modules before integration testing. Although traditionally done by developers, quality assurance engineers may also conduct unit testing due to developers' reluctance to perform this essential testing. The objective of unit testing include isolate code sections, verifying code correctness, testing every function and procedure, early bug detection to save costs, aiding developers in understanding the code base for quick changes, and facilitating code reuse. The workflow of unit testing involves four main steps: creating test cases, review, establish a baseline, and execute test cases. First, test cases are created to validate individual software components. Then, they are reviewed for accuracy and coverage. A baseline is established as a reference point for future comparisons. Finally, the test cases are executed to verify functionality and identify any issues. Next up, we have integration testing. Integration testing focuses on verifying the interaction between different modules or components of software to ensure seamless functionality and compatibility. It's essential to detect faults in the interface between integrated testing unit. Types of integration testing. First one is Big Bang integration testing. All modules are integrated simultaneously and testing is conducted as a whole system. Second one is bottom-up integration testing. Integration starts from the bottom layer of the software architecture, progressively moving upwards. Third one is top-down integration testing. Integration begins from the topmost layer of the software architecture, progressively moving downwards. Mixed integration testing. Combination of both top-down and bottom-up integration approach, aiming to achieve comprehensive coverage and efficient testing. Our third key automated testing is regression testing. Regression testing ensures that modification of code base haven't introduced a new defects or adversely impacted existing functionality. It is crucial to maintain the integrity of software after changes are made. When changes are made to the source code leading to failure in existing tests, debugging is done to identify and fix bugs. Modified parts are tested using selected cases with new ones added if needed. Regression testing uses these cases to ensure that changes haven't caused any adverse effects. This is the workflow of the regression testing as you can see in the image. Techniques for the selected regression test cases include all existing test cases, random selection, modification transversing to cover altered code, and prioritizing based on bug detection and customer needs. So guys, when it comes to ensuring the quality of new software application, we are presented with a critical decision. Do we opt for manual testing, relying on human testers, or do we embrace automated testing, leveraging the script to execute predefined test cases? Each approach comes with its own advantages and disadvantages. Now let's pause and think about this decision for a moment. Which approach would you choose and why? If we lean towards automated testing, it is crucial to consider which specific tools we would utilize to streamline the process effectively. These are my image sources, and thank you.